Sir, it's not audible.
So now when it comes to the sensors and actuators, so now here what will happen? So they are basically the next chapter is your sensors and actuators. So in the embedded system, it is basically used in a real-time world for controlling and monitoring functions with via accordance with the changes in the happening in the real-time world. Okay. So now we are going by using the embedded system, we are going to control or monitor. Okay, so we are going to control or monitor the things. So like your brake system, maybe it may be a brake system or airbag, or it may be AC, or it may be a. So when you are working now, you have the app that how much steps you have been calculated. So how we are going to get that one? That is nothing but the sensors which will be there, which will check that how much steps has been used by you people. Okay, that is one typical examples what you are going to have. Okay, so whenever you are going to enter a class, they can sense that so how many people have entered the class or how many people are there inside the class that may be designed by you people. So with respect to the embedded system. Okay, so now when you are going to have this particular embedded system, so we are going to have this particular type. Okay, so when you are going to have this embedded system, so it is going to have the embedded system here, as you can see. uh, Typically what it is going to have, so typically it is going to have the embedded system. So embedded system will be having one input and one output. Okay, so in that particular input, it is nothing but a sensor which you are going to have. So at the output, some action has to be taken. The action will be taken by the actuator. So now, so it is here what you are going to have is a control variable which you are going to have to control it. So control variable you are going to have, so that is going to control the things. Okay, so that's what is happening. So now the change in the system environment or variables are detected by the sensors. Okay, these sensors will change, detect what is happening in the outside world. So that is the derivative of sensors. It is uh, it may be outside environment what is happening, it is going to detect you. So it is going to be outside environment, depending upon the embedded system will process it. Okay, so it is nothing but it is similar to your microprocessor. So it is going to process it, embedded system. Now after processing it, so it has to take the action, right? So the actuator is going to take the action. What action it has to take? So here, if we take your normal car, so if your sensor is what? So the pressure sensor it will be there. So in the pressure sensors, whenever the car is met with the accident, it will check that what is the pressure of that particular of that impact. So pressure it will check, the embedded system will process it depending upon the pressure. So depending upon the pressure, so the actuators what it has to do, the actuators has to open airbag, open airbag or not. That action it has to take. So this is a typical example of your sensors and actuators, what you are going to have. Okay, so in an embedded system, for using the controlling purpose, the system will produce some change in the controlling variable to bring the controlled variable to a desired value. So what it means, so you're going to have the controlling variable here. Okay, so you're going to have the controlling variable at the inside input side, and whatever the action after taking the answer, so you're going to have the controlled variable. So to bring back that particular control variable to some point. So to some point it has to bring to some point the control variable has to be brought. Okay, so that's what typically sensors and actuators is all about. Okay, so the changes in the control variable is achieved through an actuator connected to the output port of the embedded system. So whatever the changes you're going to have in the control variable is achieved through an actuators. Okay, so next comes the definition. What do you mean by sensors? So we discussed about what a sensor is and why is it used. So there are different types of sensors are there. So now when you are going to have the sensors, when you motion it, when you sense it, so it is not going to be sensed and it is not going to decide that what action has to be taken. So now it has to convert from one form to the another form. This before it gets decided. So now a sensor is nothing but a transducer. Okay, sensor is nothing but a transducer. So next comes the question: what do you mean by transducer? So transducer is nothing but what? So here we are going to have the transducer. So have you heard the word transducer? Anybody? So here the transducer, what it is going to do is it is going to convert. It is going to convert one form of energy to another form. So it's going to convert one form of energy to another form. So now, if we take an example, so if we take this particular definition and that another form, what is this going to be get? The another form, it should be used for measurement. it will be used for measurement. So that you have to keep in mind. That should be used for the measurement purpose. So that's what your sensor is going to be used. Okay. So it acts as an input device. As I told you that the sensor will be acting as an input device for your embedded system. So like the sensors are there, which will calculate the quantity, number of steps are there. So the soil moisture sensor is there to calculate the what is the moisture in the soil in the agricultural field. They are going to make use of that one. So they are going to have the sensor that is nothing but infrared obstacle aero balance sensor module is there. So next is ultrasonic sensors are there. Okay, so there's a number of sensors are there. Okay, so next when it comes to the actuators, so actuators are nothing but what? It's a form of the transducer device. So which converts signals to corresponding physical action. As I told you that, so whenever that so in your actuators, what will happen? So here in your sensor, what will happen? So whatever the mechanical energy in sensor, it is going to convert mechanical energy to signal. So it is going to convert mechanical energy into signals. Okay, so a signal is nothing but it is represented in digital form. Okay, it is either in analog form or digital form. It is going to convert it. So mechanical energy to electrical energy. Okay, it is going to convert to electrical energy where is the form of the signal. So whereas your actuator, what it does is it is reverse process. So it is going to convert your mechanical energy to it is going to convert the mechanical energy, not mechanical energy. It's going to convert the electrical energy. Okay, so your sensor, if you take the sensor, so it converts mechanical energy to electrical energy. So it converts mechanical energy to electrical energy. So actuator is going to do the reverse process. So if we take the actuator is going to do the reverse process. So it is going to convert electrical energy or signals. Okay, so the electrical energy previously they are calling it as by signals. So it is going to convert the signals into mechanical energy. Okay, so that's what the operation is going to do. So it is going to convert the energy. So it is going to convert the electrical energy. Okay, it's going to convert the electrical energy. So into mechanical energy. Okay, that's what the process it is going to do. So it is going to check for the light intensity. So it may be increasing or decreasing the intensity of the light depending upon the type of operation it has to be performed. Like your webcam may be there. Webcam they are used to take the video. Depending upon the video, what motion sensors will be used. In the motion sensor, it is nothing but it is going to detect the motions in front of the door. So if any unusual activity is happening inside the door, so then it is going to sense you, indicate that something is unusual, I think, is happening in the house. So you have to check, you have to take the action correspondingly to that one. So that is what the actuator is going to do. So next is your sensor and actuators. What this particular sensor and actuators is going to have. So it is going to have, if we take this particular Arduino board, so you're going to have the relay. So relay you're going to have, so this will be acting as a switch. So you're going to have the relay. So light sensor will be there, temperature sensor will be there. So infrared receiver, buzzer, potentiometer. So this is one typical example of the embedded system which you're going to have. Like push button will be there, potentiometer will be there, which will vary the resistance or it will vary the sound also. Digital analog pinouts will be there where it will be connected here. Okay, these are some of the components which will be present in your sensors and actuators. Okay, so if it has to perform properly, so it requires IO subsystem. Okay, if your sensors and actuators has to work properly, it requires the IO subsystem. So what this IO subsystems is going to provide all about? So it is going to basically facilitate the interaction with the outside world. So when you are doing the operations, you have to connect to the outside world. So who is going to do the interaction? After that, we are telling that actuator is going to convert from electrical to signals to electrical energy to mechanical energy. So after getting it one, so how the interaction has to be done with the sensors and interaction. So interaction will happen using sensor actuators, where it will be connected. It will be connected to the input and output port. So you can see it here. So those interactions is going to happen with the sensors and actuators connected to the input and output ports. So now here, whatever the sensors you are going to have, the sensor are not directly connected to the input port. Okay, so the sensors which are there, the sensors will not be connected to the directly the input port. So, but they are transfer interface using translating system like ADC or optocouplers. So where you are going to have sensor is not connected to the input port directly. So instead of that one, it will be connected to the ADC. So that means you are going to have the sensors. So sensors, if it has to be connected to the input port, so in between there will be some analog to digital signals will be there, which will convert that one. After that one, it will connect to the input port here. So input port here. So that's how the port, that how the sensors will be connected. So they are not connected directly to the input port. So they are interfaced using translation system like ADC or optocoupler. So that means either it may be from your ADC means it is or so another component which they are going to use is optocoupler. So why you are going to make use of the optocoupler? So optocoupler is a combination of what and what? It's a combination of your
D and
photodiode and LED.
photo.
Okay, so it works both with the principle of photodiode and LED. So this is where the optocoupler application will be coming. So when you are going to use, when the light is fall on that one and some action has to be taken, so it is going to convert the photodiode will sense that what action if a LED will give you the light. So whereas the photodiode is going to sense the light. Okay, so that's what it's going to happen. So the IO system which we are going to use discuss here is you are going to have LED, 7-segment LED display, optocoupler, okay, and then stepper motor, relay, piezo buzzer, push button switch, keyboard, and programmable peripheral interface. Okay, so I think you know LED. So LED, you know, so LED is nothing but light emitting diode. So since you have been studied already, so I will skip this particular part. So next is how it has been 7-segment display. Also, I explained in the last class on last AD part only. You just go through it again. How that particular numbers will be interface. So you go through the same part. So since I have explained, if you have any doubts regarding that one, can I skip this particular part, students? Because I have explained already all these terminologies. So 7-segment display. So it is nothing but the output device for displaying alphanumeric characters. Okay. So it contains 8 segment. So as it told us, it is going to have the ABCD. So your ABCD, there are 2 types, as I told you in the last semester only. So it's going to have 2 types. If you take the LED, what are the 2 types? One is common cathode type, other is common anode type. Okay, common cathode type, other is common anode type. You are going to have common anode type. You are going to have. So next, once it is representing the numbers. So if you can see it here, as I explored yesterday, last semester only. So it will be having the hexadecimal number. So always when you are going to have the common anode, so common anode means nothing but what? Your anode is connected commonly. You can see it here. So the anode is connected commonly. So now when you are going to have the different 8 segments, A, B, C, D, E, F. So how it is represented in your LED? So in your 7-segment, this is 1, 2, 3, 4, 5, 6, 7. Okay. So like this segment will be taken. This will be A, B, C, D, E, F, G. So this is how it will be represented. So now, whenever you are going to have this particular part, so in your converting from analog to digital, okay, so it will be A, B, C, D, E, F, G, okay, H. So depending upon the corresponding elements to be on, that particular LED should be on. So if it is for 1, BC will be on. That means your B will be 1, C will be 1, others will be 0. Similarly, if I want 2, so 2 will be like this. So A will be on, B will be on, C off, A, B, C, D is on, E is off, then G is on. So that means it is going to have 1 here. So F is 0, E is 1, D is 1, so C is 0, B1, E1. So now this has to be converted to hexadecimal value. So this has to be converted to hexadecimal value and it will be represented. You can see it here. So if for 1, so if it is for 1, BC is on. So you can see it here from the figure. So if the 1 is there, the BC will be on. So the BC on means for the hexadecimal code for BC is 06H. Similarly, if I want to 3, for 3, A, B, G, C, D. Hello? Yeah.
The
way you're
screen is
writing
lagged.
is
This one, right?
yes.
I have to write it and show. Okay.
No, sir, if you are writing, it is lagging, sir. It is not visible.
Okay. Okay. In PPT, it's okay, right?
PPT is not seen, sir.
Now,
The whiteboard is seen.
now, whether it's able to see that one?
No, sir.
Okay. 1 minute. Can you able to see the PPT now?
Yes, sir.
Okay. So now here, so I will go with this one only. So now here you can see it common anode LED display. So here what will happen here is, so you can see it here, A, B, C, D, E, F. Okay. So now corresponding segments will be turned on. So that means A is one LED, B is one LED, C is one LED, D is one LED, E is one LED, F is one LED, G is one LED. So corresponding segments will be turned on in your common anode segment. So and then after filling whichever the segment, whichever the LED is on, I am going to present one in that one. So you can see it here. So to represent one, to display the character one, I should have B and C to be one high. So B and C, I am making it as high 1 1. So remaining all will be 0. The corresponding hexa code what you are going to have is will be 06H. Okay. So now similarly for 3. So if you want to for 3, so you're going to have what? A should be 1, B should be 1, C should be 1, D should be 1, and G should be 1. So if you fill it and the hexadecimal code, what you are going to get is 6FH. Okay. So any doubt in this one now? How to represent your hexa code for your 7 segment LED display? Anybody having any doubt? Any doubt?
No.
Okay. So next it is common cathode here. So you can see it here. It is reversed here. And whatever the H will be there, point, it will be displayed as 1 in the common cathode. The same thing, it is reversed now. So instead of going from wherever the representation of A to B is going from right to left in your common anode. So wherever the representation of A to B is going from left to right in your common cathode. So that you have to keep in your mind. Okay, that you have to keep in your mind when you are representing your using hexa code, because this particular code is you are going to use when you are making use of microprocessor programming. Okay, so when you're doing the programming, how to interfaces, what are the hexadecimal code you have to send to that particular microcontroller to display, you have to send this particular code, that is like F9H is there, right? To display the particular number, what is the corresponding hexa code you require? The corresponding hexa code what you require, you need to transfer that particular code there. Okay. So next, optocouplers. So there is a combination of LED and phototransistor. So this I'm going to skip it. So since you already know, you just go through it once. So next is stepper motor. So stepper motor is an electromagnetic device, okay, which produces discrete rotation when an input voltage is applied to it. So you can see it here. So as the name indicates, so the stepper motor. So what the stepper motor will be having? The stepper motor is an electromagnetic device. So can you able to see the screen now? What screen?
Yes,
So,
sir.
so you are going to have the stepper motor. So in your stepper motor, what it is going to have, so you can see it here, the stepper motor is an electromagnetic device. Okay, it is nothing but electromagnetic device which you are going to have. So electromechanical device which will produce the motion. Okay, which will produce the electrical motion. Which will produce the electrical motion. Okay, so it will produce the electrical motion and it is going to make use of that one. So they are mainly used in industrial embedded system. Okay, this particular stepper motors are mainly used in industrial embedded system, consumer electronics and robotic control systems. Okay, so whenever you want to move the hand of a robot, so you can require the stepper motor. Okay, so when the leg has to move in the robot, so you have to make use of the stepper motor. So it is basically used in designing the robots. Okay, it is mainly used in designing the robots. So if we take the best upon the windings which you are going to use, the stepper motors are classified as unipolar and bipolar. Okay, so unipolar and bipolar is going to be used. So whereas in your unipolar stepper motor, it contains 2 windings per phase, whereas in your bipolar, it is going to have the 4 windings per phase. So the direction of rotation of a stepper motor is controlled by changing the direction of current flow. So you can see it here. So it is basically works on the principle of electromagnetic induction. So all of you studied your electromagnetic induction in your physics, I think, in your second PO. So this particular direction of rotation of a stepper motor is basically controlled by the flow of current. So that is going to be controlled by changing the direction of the current flow. So now when you are going to have this particular part, so current will be one direction if it has to flow in the clockwise direction. So if it has to, if the stepper motor has to go in the reverse direction, then you have to provide the current in the anti-clockwise direction. So now, so it is easy to shift the rotation. So either it may be a clockwise or anti-clockwise by just giving the voltage in the reverse direction. So just if you give the current to flow in the reverse direction, obviously the current will be in the rotation of the stepper motor will be changed. Okay, so that's what. So in the so now in your bipolar, what will happen? The bipolar stepper motor contains single winding per phase. So you can see it here. So you're going to have only 2 windings here. So that is A, B, C, D. So combine the motor. So it's going to have 2 windings per phase. So if one phase means what? If one angle has to be rotated, it requires 2 windings. Okay. If one rotation has to be done, 2 windings has to be there. So now if it is, you can see it here. So inside this one in bipolar motor, so it's going to have 1 winding per phase. That means 4 directions will be there in your bipolar. All these stepper motor kind of single winding per phase. So that means if it are to have the north direction, it is having 1, west is going to have 1 phase, 1 winding, south is going to have another winding, and east is going to have 1 winding. So that's how the phases will be designed. So that I think you have gone through in your electrical class. So we don't have to go in depth here. So now in your bipolar, for reversing the motor rotation, the current flow through the windings in reverses automatically. So for reversing the motor rotation, the current flow through the windings is reversed dynamically. So as I told you previously in unipolar, so if I want to reverse the direction of the motor, we have to give the reverse current. Okay, so if you give the reverse current, so obviously the motor will be rotating in the anti-clockwise direction. So if you go with the, yes, what is the problem? Nandish? Okay. So now it requires complex circuitry for current flow reversals. Okay. So it requires complex circuitry for current flow reversal. So now next is relay. So relay, all of you, how many of you heard the relay? How many heard of relay? So it is normally used in your home also. That is nothing but your normal switch. Okay. So relay is a electromagnetic device. So it is basically act as a switch. So whenever the current is applied to that particular thing, either it will switch on to off or off to on. So it acts as a dynamic power selectors for signal and power. So you have gone in the home. In the home, you may have seen the 2-way switches are there, right? So in the 2-way switches, these are the concept what they have used. That is relay. So it basically works on electromagnetic principle. Okay, it basically works on your electromagnetic principle. So when voltage is applied to relay coil, current flows through the coil, which in turn generates the magnetic field, which attract the armature cord, moves the contact point. Okay, that's what it means. So it basically, if you talk about your all your embedded system, most of the embedded system, either it may be relay or it may be stepper motor, all will work with respect to electromagnetic principle or electromagnetic induction. Okay, so electromagnetic induction or electromagnetic principle, both are same. So now in your whenever the voltage is applied to that particular coil, what will be done? So the coil which will be there, so in turn the coil, the current is going to be flowing inside the coil. Once it's going inside the coil, it is in turn generates the magnetic field. Okay, when it in turn generates the magnetic field, it tries to move, which attracts the armature core. Okay, so it attracts the armature core and mostly contact point. So what it wants to, how it is going to have. So when you talk about the relay, it's going to have two types, three types. One is single pole, single throw, normally open. Single pole, single throw, normally closed. Single pole, double throw. So in your double two-way switch, you are going to use the single pole, double throw. In your normal two-way switch, which you are going to use in your home. So that is single pole, double throw. Okay, keep in your mind. It is normal switch which you are going to use in your home, which is a two-way switch. So in most of your home, they have used a two-way switch, right? The two-way switch which you are going to use in your home is of make single pole double throw switch. Whereas your normal switch, what they are going to use is of single pole single throw. Okay, so when you are applying, when your switch is on or switch is off, that it is going to be electrically. So, but in relay, what will happen? It will be done automatically. The switch is going to open or close automatically. That's it. That is nothing else. Whenever the current flows, if it is on, it will turn off, or if it is off, it will turn off. So automatically it will be using. So this is where you can use for automatic door locks or automatic car, automatic controller of light. So when you are going to make use of the automatic controller of appliances, you can make use of the relay, which will be acting as a switch. Okay, depending upon the instructions what you are going to give. So this is all what about the relay. So next is piezoelectric buzzer. So all of you know the buzzer which they are going to use. So it's an output device. So it's a piezoelectric device for generating audio indications in embedded applications. Okay, so it contains the piezoelectric diaphragm which produces audible sound. Okay, all of you have seen this particular piezoelectric buzzer in your vehicles, that is your two-wheeler. So in your two-wheeler, where you are going to make use of, in your signal indicator. Okay, so this particular piezo buzzer is going to be used in your signal indicator to signal, right? That you are going to have the sound, right? When you are putting the indicator in your vehicle. So from which it is going to get, so that is going to get that particular sound from your piezoelectric buzzer. So it is going to generate what? It is going to generate the audio indications in the independent applications. So even if you are taking the signal indicator is also a type of the embedded application, because when you switch, when you put the switch to the right side, only the right side indicator has to turn on. When you turn it to the left, the only left side indicator has to turn on. So it's also one of the type of the embedded device which you are going to use in your day-to-day life. So now, with respect to the voltage what is applied to that particular piezoelectric diaphragm, so it is going to produce the audible sound. So it is going to be available in two types. Okay, so if you take the piezoelectric buzzers, it is going to be available in two types. One is your self-driving, other is external driving. So one is your self-driving, it is going to have, other is external driving, it is going to have. So next, self-driving contains all the necessary components to generate sound as a predefined tone. Okay, self-driving contains what are the necessary components to generate sound at a predefined tone. So it is nothing but what? So you are going to have the predefined indicator sound will be fixed in that particular buzzer, like in your vehicle. So it is going to have fixed sound, right? So it's going to have the fixed sound like p. So it will sound that one and it will go. So but the external driving piece of buzzers, it supports the generation of different tones also. So that means, so there are multiple tones will be there in that particular buzzer. So with whenever you require a particular tone, you can configure that particular piezo buzzer to have that particular tone. So that is about your external driving piezo buzzer. So then you are going to have the push button switch. So it acts as an input device. So whatever the switch you are going to have in your sensors and actuators input device, so it will be acting as an input device. Acting to the push button switch will be acting as an input device. So it was going to have your push button switch is coming in two configuration. One is push to make, other is push to break. So push to make is nothing but what? It will be normally open. So whenever you are pressing the switch, it is going to make a contact. So push to make is nothing but what? Whenever you are going to press that particular button, it is going to make a contact. So push to break is what? So normally it will be closed. It break the contact when switch is pressed. That means what? It will be normally off. Okay. So normally off. So whenever you want to do it on, you have to press the switch. So push button is normally used for generating a monitoring pulse. So that's how it is going to generate. You can see it here, low pulse generator. So you're going to have the push switch. So here you are going to press it, 4 pins. So it is going to generate the low pulse. Why it is called as low pulse? So in what type of circuit it is now? Can anyone tell? From your basics of your ADE, when you take the biasing configuration, what type of circuit is this particular part is about? So this is where your designing of your circuits will play important role. Okay, designing of your circuits will play an important role. So this is typical to your voltage divider bias circuit, right? So this is a voltage divider circuit. So the voltage which will be appearing at this particular point will be uh, VCC into opposite resistance divided by sum of the resistances. That's what it is going to have. So push button which you are going to have, it can generate either low pulse or high pulse. Okay. So depending upon the type of the circuitry. So this is going to generate if your switch is present between your uh, far away from your VCC, then it is going to have the generate the low pulse because of the voltage divider circuit. What I told, what will be the voltage appearing across this particular point, that is this particular switch. So if it is going to have the VCC, so it is directly VCC, it is coming here. It is not divided. The voltage is not divided. So if the direct VCC is given to that particular switch, so it will be high pulse, which you are going to have. Okay. So that means the directly VCC will be going to the output. So here, whereas in your first circuit in the low pass generator, so if the switch is at the bottom side, so the voltage which you are going to have, that will be divided. Okay, once it is divided, it will reduce the voltage which is appearing across that particular point. Okay, so that's what your high pulse switch and low pulse generator and low pulse generator is going to tell. So this is what the micro 4x4 switch which you are going to have. So that means you can see it here, 0, 1, 2, 3. These are the switches 4x4. So it will represent the hexadecimal value. Okay, it will represent the hexadecimal value. So this will be having the switches 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 8, 9. The hexadecimal value of 10 is A, B, and C, D, E, F. Okay, so that will be connected to your microprocessor port. So you're going to have the port through which you are going to do the interface. That I am going to tell you in next chapter, which is 8255. So that is programmable peripheral interface. How you are going to interface with your mobile devices. Okay, not mobile devices with respect to microprocessor or embedded devices. Okay. So next, when key are pressed or more, push button is not possible. So this is what I explained. So this is having the 4 rows and 4 columns and offered up to 16 pins. So it is going to be working on the scanning techniques. Okay, scanning techniques by pulling row matrix to low, it will read column. Okay, so it is going to as a row matrix to low to read a column. So the process is rotating till the key is pressed is held at low. So the key, whatever you are going to use, it will be used as a mechanical device, and it will be as a debounce circuit. To overcome the debouncing, appropriate debouncing circuit will be applied. So which one you are going to use for debouncing? Can anyone tell? Where you have heard this particular debouncing circuit? Where you have used this particular debouncing circuit? Heard of debouncing? I want
Switch
the answer from switch debouncing. Why you are used that one?
Sorry, we use SR latch to eradicate switch debouncing.
Yeah, SR switch or SR latch only are used. For what purpose it is been used? So that it should not oscillate between the states, between high and low states, right? For that particular purpose, you have used the debouncing circuit. Here also the same thing. Whenever your key press the key, you should not get the wrong value. So to overcome the wrong value which has been entered. So if I press 4, the 4 has to be there. So for example, if it's 3 is there previously, if I press 4, it should not oscillate between 3 and 4. So it should get the value 4 directly. Or it should, and it is going to, it should change from 3 to 4. So for that particular reason, we are going to make use of the debouncing circuit in your keypad. Okay, so that is how it is going to be used in your keypad. So that is 4 cross. This particular keypad, what you are going to have is 4 cross 4. So you can see it from the figure. It is going to have 4 cross 4. So you're going to have 2 ports. One will be the input port to configure. Other will be the output port. To select the corresponding ports, so you have to apply the signals to this particular port, either to D0, D1, D2, D3, or D0, D1, D2, D3. So this will be across row column. Okay. So this will be at the row side. So this particular microprocessor port will be at the row side. So which will be at port 1. Port 1 is looking after the row numbers. Okay. Whereas your port 2 is looking after the column numbers. So your port 2 is looking after the column, where port 1 is looking after the rows. So this is how it will be. So whenever the keys are more, push button is not used. Okay, when key requires are more. So when key requires are more, what happens? This particular push button is not useful, because when the number of operation what you need to perform is more. Because when you want to control more number of appliances, for example, so in your home, so I want to have more number of switches to be there, right? So when you want to have more number of switches, I cannot go with the push button switch. So we are going to make use of the keyboard. Keyboard which will be scanned. So it will be having the totally 16 switches will be there. So depending upon the 16 switches, you are going to make use of that particular board, and you are going to communicate depending upon the keys which has been pressed. Okay. So this way here, you can see it here. It will be arranged in matrix form. So column is hold low and row is hold high to read the next row. Okay. So that's what it is going to have. So if you want to read the low, if you want to read the rows from low, so all these column pins should be made low. So and then your row device, row matrix should be made high. So only at that time you are going to read that particular row, what it is. So till the process is repeating, it is internally it will be repeating. Okay. So again and again till you press some key. So that is how it will be read. So that you come to know understanding better when you are doing the lab with respect to the hardware. There is keyboard interfacing is there as part of your lab. So when you study that particular keyboard interfacing, you understand that what is happening with respect to that particular device. Okay. So that's what it is going to happen there. So that is about your remaining IO components. So your 8255 is more important. Okay. So it requires a block diagram, and the pin numbers will be there. So this I am going to do it tomorrow. So anybody having any doubt? So just go through the LED, 8 segment, 7 segment display, piezoelectric buzzer, relay, push button, and then keyboard switch. Okay. So these are important. So I don't, because we are completing, because you are the first time, you people are the first people who are writing the microcontroller exam. Okay. So now what is the problem when you are writing for the first time? When you are writing for the first time, the first revised syllabus, what's the problem you are going to face? Can any